everyone, class 9th champions, class 9th ninjas. So welcome back to lecture number 2 of sets. One of video of lecture number 1 of sets has already been uploaded on channel. I hope, I'm pretty much sure you guys have already watched that video. Then only you guys will be enjoying this lecture number 2 if you have already watched the first video. Otherwise you will be feeling little, you will be stucking somewhere, because lecture number 2, to get the lecture number 2 concepts clearly and comfortably, you should watch the lecture number 1 also. Okay, so let's begin lecture number 2 sets. So basically in this today's video we are going to talk about subsets. First, types of sets. How many types of sets are there? Subsets, cardinality, Venn diagrams, theory, and few examples of these topics. So let's move ahead without making any delay. So what we will cover in this video, basically we are going to talk about revisiting a set, basically definition, notation, and 2 standard form of representation. And the most important part here is, the most important thing we are going to talk about types of sets. What is called empty sets, singleton sets, finite set, infinite sets, equivalent sets, equal set, and universal sets. So many things are there we are going to talk about. Now, what is called subsets? What does it mean by subsets? Subsets and cardinality. This is very important. The cardinal number, NA, and the addition formula, everything, and Venn diagram. This is really very interesting and very important also for your higher standard. If you guys are aiming for JEE and any type of prestigious examination ahead in future, so this topic, these things are really important for you all. Okay, move ahead. So let's talk about revisiting sets. So few things about set. So what is the definition of set? A set is a well-defined collection of distinct objects. We have discussed these things in previous video. So I'm recalling again, just short overview once again. So a set is a well-defined collection of distinct objects. Each object is called an element and a member of the set. Okay, for example, the notation is capital letter. We always use capital letter to represent a set. For example, natural number set. So we can write n natural number 1, 2, 3, 4 ... and bracket close. We always use this curly bracket to represent a set. Okay, and 1, 2, 3, 4. These are called elements, and this is entire function is set, and set always represent a capital letter, from a capital letter. Elements are a small letter. So if you want to write any alphabetical things inside the curly brackets, so always write small. Elements always come in a small format, and the sets represented by capital format. A belongs to, this E is called belongs to, and E cancelled, crossed E is called does not belongs to. So A means, this A means belongs to, and this E not belongs. So please make sure to store these notation in your mind, that will be using further in future. So 2 forms of representation. So we represent sets in 2 forms. First is called roster form, in which sets are represented in bracket and elements will be there. And the second is set builder form. In set builder form, sets are represented in language, a system. So a property will be there, and we can change set builder into roster and roster into set builder. So both are interlinked with each other. So when we show the elements with comma, this is called roster, or we can say tabular form, and this is called set builder form, in which we have a pattern and information by using which we can write the roster form of set. So this is called a defining property common to all the elements stated. Elements are listed separated by commas inside the curly braces. So when the elements are there with comma between each element, this is called roster form, and this property is called, the property format is called set builder form. Everything I have discussed in the lecture number 1, please go and watch the lecture number 1. Okay, now let's talk about this video. What is the intention, what is the motto and target? Today's target of this video is this, types of set. So my dear, the first is types of sets. What is called, how many types of sets we have? So first is called empty set. What does it mean by empty set? Empty set is represented by phi, or like this, nothing will be there inside this curly braces, nothing, no element will be there. So both representation we use to represent empty set. Now what is called empty set? How we can write empty set for any information? For example, if I ask you, write a set of even number less than 2. So there is no such even number less than 2, because the first even number starts from 2. So there is no any possibility to write the given information in elemental form. We can't write. If I ask you, write an odd number less than 3. So this is possible. 1 is the odd number. But if I ask you, write a negative number greater than 4. Negative number greater than 4? 4 is positive, so there is no any possibility to write a number in negative form and greater than 4. No possibility. So such sets are called empty set. So empty set represented by phi. This is called phi, and curly braces with space between both the brackets. Nothing will be there. So no elements at all. If no elements are at all, we can say that empty set. Clear, everyone? Next comes up is singleton set. What is called singleton set, champions? So singleton set means when the set is having only one element. Only one element. For example, if I ask you, write a set of a rational number, any rational number. Write a set to represent a rational number. So you can write a rational number. For example, R is equal to rational number. So let's say 1 by 2. Only one rational number. I have asked you to write only one rational number, so only one element will come. So such set is called singleton set. Singleton set. Are you getting my point? So singleton means what? When the set is having exactly one element. Only one element. I hope clear. Empty, no element. Singleton, one element. Now, finite set. Finite set means a set which is having, limited number of elements. The limited number of elements. It means we can count the number of elements. We can count there will be no dot. The elements will be ended up. I mean, the elements will be there and we can count them. Countable number of elements. So finite set, countable number of elements. For example, this is a set 1, 2, 3, 4. We can count how many elements are there. 4 elements. For example, I have a set A, B, C, D, 1, 2. For example, this is the set here. How many elements are there, guys? How many elements? 1, 2, 3, 4, 5, 6. We can count. So the number of elements is countable. So this is called finite set. But if the number of elements are uncountable, infinite, so at the end 3 dots will be there. Dot. And this dot indicates, we say this and so on. And so on means it is continuously going. Infinite. We don't know what will be the last term, what will be the last element, because the set is still continue. So such set is called infinite set. So infinite set means uncountable, unending. There will be no end. But here there is an end. This set is ending at 4. The elements is ending at 4. So this is called finite set and this is called infinite set. Getting my point? So clear? Empty set, singleton set, finite set, infinite set. Moving to next. Now the next point is equal set. What is called equal sets? So basically equal sets means a set which is having same elements. Same elements, guys, same elements. For example, I have a set 1, 2, 3 and I have set B 3, 1, 2. It may be in random order, doesn't matter. But 1, 2, 3 present, 1, 2, 3 are the elements of set A and 3, 1, 2, I mean 1, 2, 3 is element of set B also. So such sets are called equal sets when the elements are same. Not number. I'm not talking about number. I'm saying same elements, whether the elements are in random form or in systematic form. Clear? Now, next is equivalent set. So equivalent sets are the sets which is having same number of elements. Same number of elements. Whether the set A is alphabetic or the set B is numeric, if the number of elements are same, such sets are called equivalent sets. Number of elements should be same. Here, the elements itself should be same. Here, only number of elements should be same. 7th is universal set. Universal set means contain all sets under discussion. For example, I have set A 1, 2, 3, right? And I have set B 2, 3, 4. Now if I ask you, what will be the universal set of this both? So universal set means combining both the sets. So 1 is present here, but 1 is not here, so we can take 1. 2 is here, 2 is here, so 2 will come at once, 3 will come at once, and 4 will come. This is called universal set. A union B, universal set. So you contain all sets under discussion. Next is power set. Power set means what? Set of all subset of A. Set of all subset of A. Listen, for example, I have set A, B. So my dear, what is called power set? So basically power set means the elements which is present in set A, let's make separately set. I mean the set of all subsets. So bracket and here this A comma B, I'm writing separately. I'm making A as separate set, B as separate set. So this is called power set. A was itself a set, but the elements of A, I am writing all the elements separately as a set. So this will be subset of A, So this is called power set. Right, everyone? So this is called, and one more power set will come. A and B will combine. Separate A, separate B, and A and B all together. So there will be 3 subsets possible. If the number of sets are 2, there will be 3 subsets possible. So this is called power set. Clear, everyone? So power set means set of all subsets of A. Right, everyone? So I hope this is clear to you all. Okay, moving ahead. Okay, let's talk about empty set and singleton set. Few questions. Okay, so empty set is also called null set. Null means nothing. Nothing. No element. When there is no element, this is called null set. No element. Okay. Look at the question. A set containing no element is called the empty set. It is denoted by phi or curly bracket with free space. So question, for example, X, A is a set X such that X is a natural number, X is a natural number greater than 2, less than 3. X is a natural number greater than 2 and less than 3. Is it possible? Not possible, bro. So we can't write any set for this given statement. Greater than 2, less than 3. And we want a natural number. Natural number can't go in decimal. So there will be no such possibility. So empty set will come because natural number never go in decimal. If we write X in decimal, we can write 2.1 can come, 2.5 can come, 2.5 will be less than 3 and 2.5 is greater than 2. But make sure this is natural number. So natural number can't be a decimal form. So null set. X such that X square is equal to 4 and X is odd, not possible. If X square is equal to 4, so X can be 2 only, positive or negative. So X can't be odd number. So this is also phi, not a set. The set of triangle with 4, the set of triangle with 4 sides, is it possible? Triangle means the property of triangle having 3 sides. So not possible. So this is also null set. Clear, everyone? So null set means when there will be no element, no possibility. Now moving to singleton. Singleton set means unit set. Unit means only one element. Only one element. Only one element is called singleton set. Let's look. A set containing exactly one element is called singleton set. For example, A is a set X such that X plus 5 is 9. So my dear, if X plus 5 is 9, so only one possibility of X can be 4. There is only one possibility. If X plus 5 is 9, so X can only be 4. There is only one possibility. So the set will be only one element, which is 4. That means singleton set. For this equation, 4 will only satisfy. Only solution for this polynomial will be 4. So 4 means singleton and single means singleton set. For example, X such that X is an even prime number. Obviously, even be even as well as prime. So even is 2 and 2 is a prime number. So only 2 will come. So there will be only one element. For this statement, only one element will be there. So this is singleton set. For example, the set of natural number less than 2. Yeah, obviously one will be there. The set of natural number less than 2. So that will be 1. So in all the statement, only one elements are coming. only one element is present. If only one element is present, so the set will be singleton set. Clear everyone? I hope this is clear to you all. Clear? So number of null set means 0 elements will be there, and this subset of 5 will be, this is 1. Clear everyone? Moving ahead. So 0 and 5 are not empty set, each has one element. Yes, if we write like this 0, so 0 is an element, 0 is an element, and if we write 5 is an element. But if there is nothing, this represent null set, this represent null set or empty set. This will not. It means 0 is an element, it means 5 is an element. Don't write 5 in curly braces, otherwise the definition will change. Moving ahead, let's talk about finite and infinite set. This is very easy, by the way. A set is finite if the process of counting its element comes to an and for finite. But if we talk about infinite, otherwise it is infinite. So infinite means dots will be there, 3 dots. This will be represent infinite set. Getting my point? Means the elements are continue, unanded, but these elements are anded. So finite, this is finite. The set of letters in the English alphabet, of course 26 letters, finite. The set of days in a week, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, finite. X says that X is a factor of 12, so X is factor of 24. So factor of 24, 2, 3, 4, 6, 8, 12, 24. Yes, this is also finite. So now X is a 2-digit natural number. 2-digit natural number means from 10 to 99. This is also finite. So all the informations will give you finite. Now look here, infinite. All the natural numbers never end. So if you start 1, 2, 3, 4, it will go till infinity. It will go till infinity. So this is infinite. -2, all the integers, infinite. The set of point on a line. On a line, how many points we can draw? So many points. 1 points will be overlapping each other. So many points we can draw on a single line. So this is also infinite set. X is a multiple. X is a multiple of 3. Oh my God. X is a multiple of 3. Multiple of 3 means the number which can be divided by 3. So many numbers will come. 3, 6, 9, 12, 18 and carry on. The set of all rational numbers, so many rational numbers, so these all are infinite, these all are finite. Moving ahead, equal and equivalent sets. Listen everyone, what is called equal sets? Two sets A and B are equal if every element, come on, focus here, if every element of A and B are element of B, then such sets are called equal sets. For example, A is having 1, 2, 3, B set is having 3, 2, 1, and look at A, the elements 1, 2, 3, and here B 3, 3, 1, 2. The only difference is the elements are in disturbed random form, but the elements are identical. 1, 2, 3 there, 1, 2, 3 here. So such sets are called equal sets, not equivalent. Equal I'm calling. So order and repetition are irrelevant, never matter in sets. So order and repetition are irrelevant. You can ignore the order and whatever is there. Okay, equivalent sets. Listen, two sets A and B are equivalent if they have the same number of elements. Yes, this is called cardinal number. Number of elements in A and the number of elements in B set should be same. Then only the sets are called equivalent. Doesn't matter set A is having an object, set B is having alphabet, set A is having a numeric number, set B is having the animal's name. Doesn't matter, they can be different from each other, but the number of elements should be same. So let's say A is a set, ABCD, ABC are element, and B is a set, 1, 2, 3 are element. But how many elements? 3 elements. How many elements? 3 elements. So such sets are called equivalent, and we represent as this. So this represents equivalent sign. Look, the elements themselves may differ. So elements may differ, but the number of elements in both the sets should be same. Here the number of the elements should be same. Here the number of elements should be same. Here elements should be same to become equal sets. And to get the identity of equivalent set, the number of elements should be same. This is the difference, guys. And look, key relation. Every pair of equal sets is equivalent. Yes, every pair of equal sets is equivalent, but equivalent set need not to be equal. If the set is equal, So the pair, they will be equivalent also, but it is not necessary that equivalent set will be equal sets, right? This is really very important. Equal sets may be equivalent, but equivalent set, it is not necessary that the equivalent set will be equal. For example, A is a set 2, 3, 4, right? And B is a set A, C, D. Look, they both are equivalent because the number of elements are 3 and 3, but they are not equal because in set A elements are 2, 3, 4, in set B elements are A, C, D. Elements are not identical, elements are not similar, so they are not equal sets, but they are equivalent because the number of elements are same. Clear? Moving ahead. Okay, now practice type of sets. So let's talk about few questions from textbook. First question, classify as infinite or not infinite. So we are having few questions given and we have to classify whether the given functions are of finite or infinite set. Look, x such that x belongs to natural number and x is less than 100. X is less than 100, and x is a natural number. So from 1 to 99. From 1 to 99 we can write the number. So this is finite. This is obviously finite. We have to write the numbers from 1 to 99 because x belongs to natural number and x is less than 100. So from 1 to 99. Next, x such that x is a multiple of 5. X is a multiple of 5 means table of 5. So up to which you can give me table of 5. Up to which you can write the table of 5, infinite. 5 1 5, 5 2 10, 5 3 15, 5 4 20, 5 5 25, and so on. It will go, it will continue. So this is infinite. This is infinite, right? The set of letter in the word mathematics. This is finite. There are limited number of letters. We can write M is there, A is there, T is there, H is there, E is there. And we can't repeat the letters. If M is repeating twice, we have to write single time. If T is repeating twice, we have to write single time. Okay, so this is of course finite. I hope this is clear to you all the students. Okay, second question. First question done. Second question. Which of the following are empty set? Okay, so let's talk about x square is equal to 9. X is even. My dear, listen everyone. X square is equal to 9 and x is even. This is not possible. If x square is equal to 9, so x must be 3. It may be positive, negative, but 3 can be there only. And 3 is an odd number. So this is basically empty set. If you write the set, this will be the answer, empty set. Not possible here. X square is equal to 9 and we want x is even. Not possible. X will be 3. So 3 is an odd number. Second, x such that x belongs to natural number and x is less than 1. X is a natural number and x is less than 1. How is it possible? The natural number starts from a and it goes to infinity, right? So x belongs to natural number, x is less than 1, which is 0.5, 0.1, 0. Which is not possible. So this is also empty set. Okay, this is clear. And this, see here, 0 is in curly, 0 is an element. So this is not empty set. This is singleton set, guys. This is singleton set because 0 can be an element. 0 can work as an element, right? So this is singleton set. This is singleton set because one element is there. 0 is not empty. This is not representing empty set. This is an element. 0 is an element here. So this will be singleton set. Question number 3. State whether each pairs is equal, equivalent and neither. So I'm giving you 3 questions, guys, homework. Try this question. This is very easy. Every question, if you have understood these theoretical part, these questions are nothing for you. So I'm giving you 3 questions as an homework. Moving to next. Let's talk about subset. What is called subset basically? Okay, very easy. So when one set sits inside another, yes, when one set is there and one set is itself sits in another set. For example, I have set B. This is set B. This entire is set B, and this is set A. And set A is entire set A is also present in set B. So it means that A is the subset of B. This is the symbolic representation. For example, this is set C. and this is set P. This is set P. So my dear, set P. So let's change C, because C is like look like symbol of subset. So let's change it. This is Q. So Q is a set and P is also set, but P is present inside Q. So basically P is a subset of Q. So we can write here P is a subset of Q. This will be the representation. This represents the subset, guys. This is not E. E means belongs to. This is some other notation. So P is subset of Q. So when a set is present in another set, so the set which is inside, that will be subset of the outside set. Okay, so listen, definition. If every element of a set A is also an element of set B, then A is called subset of B, and this is the representation. If A is not a subset, we write this. If A is not subset, for example, here B and this is separate, C. So what will be the relation? Both are separate, so B is not subset of C, or C is not subset of B. But if a set is present inside another set, this will be the representation. Okay, so if A subset of B, it means that X belongs to A and X is an element, for example. So X is an element, so X will be belonging to A also and X will be belonging to B also, because A and B both are subset of each other. So B is then called a superset of A. Written B, this is the notation. If A is the subset of B, so B will be called superset. A is the subset of B, so B will be superset. Right, for example here, if P is the subset of Q, Q will be the superset. This is subset, P is subset of what? Q, and we can say Q is what? Superset of P. In reverse, we can say Q is superset of P and P is subset of Q. Okay, so proper set, A belongs to B. If A is subset of B and A is not equal to B, B has at least one element not in A. Empty set, phi is subset of every set, phi is subset of A. Every set is a subset. So these are the four categories in subset. Moving ahead, let's talk about power set. These are the important things. So the set of all subsets. This is really interesting, guys. Okay, the collection of all subsets. The collection of all subsets of a set A is called the power set, and it is represented by PA. For example, listen everyone, if the total number of element in A is n, and number of PA will be 2 to power n. So basically the number of power sets, when we write power set, the number of elements in power set will go in this format. If number of elements in set A is n, so the number of element in power set will go in 2 to power n. Let me show you how. Listen, if number of element in set A is 0, empty set, so how many subset will be there? Only one subset. If number of elements in set A is 1, so how many subset will be there? A subset. 2 subsets will be there. Okay, if the number of elements in A is 2, for example A and B, how many subsets will be there? For one element, 2 subsets. For 2 elements, 4 subsets. For 3 elements, 8 subsets. And if number of elements are 4, how many subsets will be there? 16 subsets will be there. Let me show you how. For example, we have AB. This is the set, and we want to write the power set for this. So power set of A will be what? Write all the elements as in subset form. So write a set, but taking all the elements as the set of this set, means subset. So my dear, first will be phi, nothing. Next, A will be an element separately. Next, B can be the element, and the next A comma B all together can be the element. This will become the power set. So how many subsets are there? 1, 2, 3, 4 subsets are there. So this is called power set, guys. So if 2 elements are there, 4 in power set, how many elements will become? 4. Clear everyone? This is really very important. So listen, listing subset of 1 to 3. So how we can write for 1 to 3? Listen, 0 elements, so 5 will be there for one element. 1, I'm taking 1 as element, so 1 we can write. For 2, separate 2. For 3, if 2 elements are there, 1 comma 2, 1 comma 3, 2 comma 3, 3 elements, 1 2 3, total 2 to power 3. And 2 to power 3 means what? 2 to ja 4 to ja 8. Total sets will be 8 subsets, power sets. So basically this is the rule, guys, by which we can write. Listen, one more thing, one more interesting part here is, if n is equal to 2, a comma b, so 4 subsets are there. If n is equal to 3, so what, how many subsets? 8 subsets. 8 subsets. Now if 4 we have 16, so it depends on even number of elements and odd number of elements. This is also the rule, guys. When one was there, how many subsets we got? 2 subsets. If 3 elements was there in set A, how many subsets we get? 8 subsets. 3 square 9, 9 minus 1 7, and that's why how many elements are there? 1 to 3. So number of subsets will be, look, 2 to power 3, 2 to power 3, 8, and 8 minus 1 will be 7. So 7 subsets will be there. 7 subsets will be there in proper subsets. Keep it in mind. This is really very important, guys. So listing subsets of 1 to 3, 0, 5, for one element, 1, 1, we can write separate. For 2 elements, we can make pair. For 3 elements, so 1, 3, 1, 4, 4, 3, 7, 7 and 1, 8. So 8 total subsets. But proper sets, 1 will be subtracted for proper sets. So 7, in proper subset, 7 will be counted. But subsets, power set, 8 will be there. Similarly, okay, let's talk about here. This is really very important, guys. Really very important. Okay, first question, insert the correct symbol. This subset, not subset. So 1 comma 2, so 1 comma 2 is present in this set also. So obviously this will be subset. So this and with line. Okay, a comma b, so a comma, oh my god, a b is here in this set, but a b is not here, so we can write this and cancel. Listen, 5 belongs, yes, 5 comes in everyone, so this will be the subset. 5 is the subset of 5 comma 7. Right, everyone, I hope this is clear. Similarly, you have these questions for practice. Write all the subset of A. So what will be the subset of, how many proper subsets? So proper subsets, 1 less. 1 less. So write the subset of this, write all the subsets. So all the subsets will be this, like this. 5 will be there. 5 P comma Q comma R, and now make pairs. P comma Q, now Q comma R, P comma Q, Q comma R, and now P comma R, and the last will be all 3 all together. So P comma Q comma R, and make sure to make this bracket. So how many subsets? 1 2 3 4 5 6 7 8 subsets. But if you want to write proper subset, so my dear, proper subset will be 8 minus 1, which will be 7. This will be the proper subset. Clear? If a set has 5, and you can solve these questions, guys. So I'm giving you 4 questions as your homework champions. I hope, I'm pretty much sure you guys can solve these questions. Okay, moving ahead. Now, what is called cardinality of a set? Cardinality means what? The number of elements present, counting the number of elements, counting the member. This is called cardinality of a set. Listen. Okay, so the cardinal number of an infinite set, finite set A, is the number of distinct element in set A. It is denoted by NA. If the set is represented by A, so this will be NA. If the set is B, so cardinal number will be NB. If the set is P, cardinal number will be NP. Cardinality is defined for the finite set. Repeated elements are counted only once. Okay. For example, if set A is 2, 4, 6, 8, so the cardinal number NA will be 4. B, X such that X is a vowel. So cardinal number, for example, vowel, oh, this is B, so let's write B here. And vowel means 5 alphabets are there, 5. C is equal to 5, so the cardinal number of C will be 0. 5 means an empty set, so the number of elements will be 0. Cardinal means number, counting the numbers, guys. Now, D is equal to A, comma. Now, A is twice, but we have to count single because repeating is ignored in set. So, the cardinal number ND will be is equal to 1, 2, 3. So, this will be 3. Clear, everyone? So, cardinality means counting the number of elements present in a set. Okay. Addition formula. So my dear NA, this is the representation of cardinality champion. So if set A is there, so number of cardinal number will be NA. Okay. Now we have a formula, very magical formula, addition formula. N means cardinal number and A union B means combining set A and B. A union B means, for example, this is set A and this is set B, for example. So the union will be this entire. This is called union, entire. This will be A union B, combining set A as well as set B, right? And this is called intersection. Can you see the common part between A and B? This is called A intersection B. Clear? So common part is called, the common portion is called intersection, and this entire combined A and B is called union. Clear, everyone? Okay. So number of A union B is equal to number of A, cardinal number of B, minus cardinal number, common number between A and B. This is really very important formula, guys. Let me put here a star. So look at the question. The elements common to both set would otherwise be counted twice. No A intersection B is subtracted once. If A and B are disjoint, number of A intersection B is 0. So my dear, this will be the result. N A union B is equal to N number of A plus number of B. When A and B are disjoint. Disjoint means when they have like this, they have separated, they are not joint. They are not sharing anything with each other. There is nothing common between both. So intersection part will be eliminated. But if they have joined with each other, set A and set B, they are sharing something, some part, some elements are common in both, right? So this part will come. But if they are disjoint, if they are separate from each other, the intersection part will remove and this formula will look like this. Clear, everyone? This is really very important. Okay, now let's talk about Venn diagram. Venn diagram is the picture set, basically. Venn diagram means picture set, to represent a set by picture. To represent a set by picture. How you guys can represent, how you guys can show the set by picture, by diagram. So let's talk about. So basically picturing sets, oh my god, this is mentioned here. Picturing sets and their relationship is called Venn diagram. So introduced by the English logician John Venn. So he was the man who introduced Venn diagram, John Venn, and that's why this is called Venn diagram. A Venn diagram represents sets by closed figure so that relationship can be seen at a glance. So my dear, you can show the set by representation using circle and all. This is called representation of set, picturing the set, and which was introduced by John Venn, and that's why this is called Venn diagram. Okay, so convention, what is the convention? The universal set is represented by capital U, and subset of U are drawn a circle. Circle represents subset. Elements may be written as points inside the figure. Overlapping circles show sets with common elements. This is the common elements. And separate circles shows the disjoint sets. If the circles are separate, this is called disjoint. If the circles are combined, so this is called combined sets. Something sharing, something both the sets are sharing. Okay, so let's talk about few important things. Guys, listen. This is set A, yellow color, and this blue part is set B. And this part, can you see here? This part, this yellow color shaded part is the sub part of B also and A also. And that's why this is called A intersection B. Intersection means common part. Intersection means, guys, common part, common element, common part of both the sets. And this entire square, rectangle, sorry, this entire rectangle, can you see? Combining A and B, this entire figure is called A union B. Combining set A as well as set B, right? So basically union means unity. Union means combination of both the sets, and intersection means common part which is sharing in both, which part is present in both. So this will be the common. This is called intersection, and this entire square is called union, in which all the set A, set B, everything will come. Okay, moving ahead. So operation shown by the Venn diagram. So there are few operations, guys. Listen everyone. So this is set A, this is set B, and if we talk about union, so what is called union? Union means, guys, this will be the union, guys. Please look at the red part. So union means all elements that are in set A or in B both. So this is called A union B. A union B means, for example, I have set A 1, 2, 3, right? And I have set B A, B, C. And if I ask you to write A union B, so what will be A union B? 1, 2, 3, A, B, C. So combining both the sets will be union sets. Set A, set B, all the elements of set A and B will be combined. Now look at the second part. Second is, this is A set, this is B set, but here this part is highlighted. So this part is sharing in both. This part is present in set A circle, set B circle. So this is called intersection, guys. Intersection means common part. Intersection means common part of both the sets. Common part. So only the elements common to both A and B. For example, set A is 1, 2, A. 1, 2, let's say 9. And set B is 3, 4, 9. 3, 4, 9. Now if I ask you, what is A intersection B? So A intersection B means the element which is present in both. So 9 is present in both. So this will be intersection. Union, all the elements got combined. But intersection, only common part will come, which is present in both. Now moving ahead, difference A minus B. So this is called complement, guys. So if I ask you A minus B, what is A minus B? Means A we have, this was A entire, and minus B, so this will be subtracted. So if we subtract A minus B, so this will be removed. So this will be considered only. So A minus B is equal to element of A that are not in B. Only element of A will be considered. Element of B will be removed. Now complement A. What is mean by complement A? Except the elements of A remaining part. All the remaining part will be considered. This is called complement. So complement A means just leave the A and this will be considered. This is called complement of A. Clear? Complement of A. Except the elements of A, remaining part will be considered. So element U that are not in A. So only B will be there. A fully L will be removed. A will be removed. So A complement the part, the space, except A, everything. So elements of U, but that are not in A. So A element should not be there in union. So all the elements of A will be removed. This is called complement of A. So we have a question here. A is this, B is this, and union we have, intersection we have. So what will be A minus B? So if A and B we have, so what will be A union B, guys? All the elements 1, 2, 3. So A union 1, 2, 3, 4, 5 will come. A intersection B, intersection means common. So 4 is present here. 4 is present here, 3 is here, 3 is here. So intersection only 3 and 4 will come, because 3 and 4 are present in both the sets. A minus B means remove all the elements of B, only A will be considered. So 1, 2, 3, 4 minus B. So 3, 4 will be removed, 5 is not here, so 5 is not counted. So 3 and 4 removed, only 1 and 2 will come. So this is 1 and 2. A union B, number of A union B. So number of A union B, we have a formula, cardinal number. NA plus NB minus number of A intersection B, this formula. So what is number of A? 1, 2, 3, 4, this is 4, plus number of B, number of elements in B, 1, 2, 3, 3, minus what is intersection? Intersection, number of elements 1, 2. Right, so 4 plus 3 7, 7 minus 2 is 5. So this will be the union. And if you count all the numbers in union, 1 2 3 4 5, wow. And by formula we are getting 5. By approach, according to rule, we are getting union 5 elements, and by formula we are getting union 5, same number. So this is all about the operation of Venn diagram, guys. Okay, moving ahead. So these are the practice questions for you, everyone. Practice cardinality and Venn diagram. So I'm giving you few questions here. NA is given to you, NB is given to you, and A intersection B will be given to you. What will be A union B? Come on, yaar. So we have a formula. A union B is equal to number of A plus number of B minus number of A intersection B. This formula, use this formula. This is really, really very important. Very important formula. I hope this is clear to you all. So number of A union B means combining both. Number of A plus number of B minus A intersection B. Everything is given here. Put the value, get the answer. In a class of 40 students, so total students are 40, 20 play cricket. So let's say this is NC, cricket for, I'm using C, 24. 18 play football, so this is, let's say, NF for football, I'm taking capital F, so this is 18, and 8 play both, so this is intersection, so this is number of A intersection means playing cricket as well as football, so C intersection F is 8. How many play at least one game? Come on, yaar, this is really easy. Everything is given to you. Now find out, solve this. So I'm giving you this homework. A we have how many elements? 1 2 3 4 5 elements. B 4 elements. Find A U B. Come on, yaar. Two sets are given to you. You have to find A union B, A intersection B, A minus B, B minus B, and verify the addition rule. Addition rule means this rule. You have to verify. Draw a Venn diagram to show U is equal to this 1 2 3 till 10. 1 2 3 4 5 6 10. 2 2 4 6 8. B this. Shed A intersection B. So by the way, you have three sets given. U set, A set, and B set. You have to draw the Venn diagram and you have to shade using pencil or pen A intersection B and write A. What will be A? And you have to shade this A intersection B, means the common part of A and B. Fifth question, in a survey of 100 people, 60 read newspaper. Okay, number of people reading newspaper. So this is NE. For newspaper you can say N. So let's say represent N, capital N for newspaper. How many? 60. 45 read Y. So let's say Y. 25 read both. How many read only X and only Y and neither? You can use what? Venn diagram. So guys, you can solve this question by Venn diagram also. And here Venn diagram. Otherwise you can apply formula also, addition formula. So thank you so much. This is the summary what we have discussed today in this class. Set revision of lecture number 1 we have done, and types, how many types of sets are there? I mean all the sets like empty, singleton, finite, infinite, equal, equivalent, universal, and power set. Subset A, subset, what about subset? A subset of B, when every elements of A lie in B, a set of n elements has 2 to power n subsets. 2 to power n subset, but proper sets, one less. So this is all about cardinality. Cardinality means number of members, number of elements present in a set. So NA represents, count the distinct elements. NA, this is the formula which is very important, we have discussed. And Venn diagram, how to represent a sets using picture form. And picture form, there is a circle for set A, another circle set B, another set C. We can use 3 circle as well. So this is all about. Thank you so much for watching. If you have any kind of doubt till here, whatever we have studied so far, lecture A, lecture 1 and lecture 2. If you guys have any kind of doubt, do let me know. In comment section, I will be giving you the solution of your doubt. Don't take tension. Thank you so much for watching. Stay blessed everyone.